Well, like, where are these aliens? Are they on, like, do we find them like by a signal from space? Do we find them like as microbes on Mars? Or maybe something like a squid on in Europa's ocean? Like, I think each of those is going to have like varying degrees of impact on our society. Because like one's just life, one's a sentient organism like the squid on Europa, and then another would be like a sapient organism like a signal from space.
Yeah, ocean. That's a cool one, right? Because like you see organisms like relatively low on the phylogenetic tree that score super high in animal intelligence, like octopi, which are a mollusk. You know, right. Snails are dumb as toast, but octopi are like smart.
Well, like, I mean, that's true. Like, intelligence can evolve convergently.
Yeah.
And it's kind of like an interesting question about like what features are needed to develop higher intelligence, because, you know, being land lovers, the two groups of terrestrial animals that have evolved like high intelligence are birds and mammals, and they evolved a lot of features convergently, like warm-bloodedness and extensive parental care, but these are largely absent from cephalopods.
Yeah, and well, the other thing about them is it seems like their nervous system is far more distributed than ours, right? Mm-hmm. Like, I want to say I don't know the figure exactly, but some wild proportion is distributed in their limbs. It doesn't seem like it's nearly as concentrated in the brain and spinal cord. Obviously, they don't have a spinal cord, but it's not as concentrated. For that distributed intelligence, what might it feel like to have your intelligence distributed in your arms? Would you feel the same locus of consciousness? Is that biologically advantageous? Of course it isn't in some sense, right? The ego protects your own interests.
Yeah.
Even though you're right, it's an illusion. But the ego serves an important biological purpose. You just wonder what that must be like.
Well, I mean, if let's say you put different parts of your brain somehow in different parts of your body, they'd still be communicating with each other in a very similar way. So you get the nerves to run there. So it wouldn't be that, I don't think it would be that different for an octopus just because the parts of the brain are spread out. Because like our brain isn't just one homogeneous mass. There are parts of it that are dedicated to different functions.
So it's a challenging question because it's also a question of getting to the baseline of things that everyone's alluding to, and Mitch is explicitly stating to it, sort of what is intelligence, right? And this anthropomorphic bias, because along the lines of what Mitch said, we're biased not only in terms of our anthropomorphic form, but also our experience of space and time.
Absolutely.
So for example, so this morning, right, I was outside enjoying myself, feeling part of the whole universe, and a little midge landed on me, flew in my ear, and I squished it. Remember that midge? Squish. Well, that midge didn't know it was bugging me, right? That midge, I'm like a mountain, right? And it's experiencing a completely different experience of space and time, trying to do its thing.
Mm-hmm.
But to me, it's just a parasite bothering me, and so I smush it. And the reason I bring that up is because I think that Mitch also hit the nail on the head talking about anxieties and social anxieties. A lot of these representations of alien life, I think, are really, again, anthropomorphic projections of our own anxiety, especially because we are Paleolithic organisms, right? Paleolithic organisms biologically with a brain that's Paleolithic, capable of interplanetary travel and quantum computing, but still with Paleolithic anxieties of the lion in the dark in the forest. And also, of course, aggression, interspecific aggression. And I think it's probably not a coincidence then that the representations of aliens look so hostile or humanoid. It's really sort of a projection of the sort of inner demons that the human species itself carries inside, right?
Yeah.
Well, I think that you're going down an interesting path because our mirror reflection is what's cast into the cosmos, right? And so we see these right? And so I think the nature of sensory perception, though. So for us, our thinking mind has dominated our consciousness But who's to say that's the case for other civilizations or species, right?
Yeah.
What if olfactory, right, or the sense of touch, or some other sensory perception was the dominant mode of interaction and processing, and their intelligence looks completely different than how we perceive with our limited thinking mind.
Well, I don't know if it would be that different because, like, one example is like we all know that dolphins are like wicked smart. We can recognize that, but like we live in a world of sight. They live in a world of sounds. So I don't know if it would be that different if they use like olfactory or
I don't know.
sound or something.
Well, what do you mean that different? I mean, our world experiences are vastly different between dolphins and humans.
Yeah, but we can still recognize and tell it like that they're among the smartest animals there are.
Well, that's our perception. I mean, how do you define intelligence?
Computational ability of the brain.
Can they? That's a limited human perspective, though. Yeah, that's true.
Yeah, I know. Like a lot of it resolves around like problem solving, things like that.
Yeah. Well, but there's a lot of latitude there because we all met in Boulder, and if you go west of Boulder about this time of year, starting about now, you start seeing the foliage change. A lot of those patches of trees are actually clones of single organisms. But it's been shown that trees, like we're great astrobiologists, engineers, but we all suck in the trees.
Right.
Mhm.
Or look at a bee colony. How intelligent are bees?
Well, that's a very interesting point because, like, I think where it would be very different, like hard to recognize for us, wouldn't be if they were like using like sound or olfactory stimuli. I think where it would be hard for us to recognize is if they, let's say, evolved out of like a hive mind, because like bees are hive mind organisms.
True, but I've heard that the Tokyo subway system, the biggest, most populous city in the world, was optimized using a slime mold.
Yeah, it's true.
Like nutrient clusters at each one of like the stations, and they were planting lines between those, and they used a slime mold to do it. And it was a very complex computational problem, and they had a biological solution of a very simple.
Yeah, I mean, look how complex the genetic code is. Look how complex our intracellular biology is.
But so in terms of slime mold, I think that I lost my train of thought, so I'll have to come back.
You're good. Yeah, I just think we need to just having some caution in terms of our expectations or projecting our own images. You say intelligence is computational power. What about the intelligence of the Earth, right? How much computational power does the planet have?
How does it do that?
It's infinitely complex, right? It's an organic system that is far superior than anything we can attempt to mimic or recreate.
Yeah, but you can't like put an input in it and expect it to solve a problem. That's
sure you can. You can. What happens when you damage the soil? There's a response.
Mm-hmm.
They're very much response inputs, and they're predictable. I mean,
that's true. That's true.
But like carbon dioxide in the atmosphere, that's a predictable response to that one.
Yeah, and I think we're finding that like more and more we look into it, there's more negative feedback loops that mitigate the impacts of global warming. There are positive feedback loops that exacerbate it.
You know what? One of the things that's interesting is that talking about computation, it's been a struggle for astrobiologists for decades now. It's a relatively new field, but we're settling into trying to come up with a manifest idea of what life really is, because all of us talking tonight, we're all astrobiologists from divergent fields, and that's how we have these fertile discussion. But there have been papers that have talked about the abiotic jumping that boundary, right? And you and I talked about this too, Patrick. the idea that hydrothermal systems are conducive to life in reducing environments. And I know that you can speak extensively to this based on your own subject matter expertise. But from a computational standpoint, there have been papers that have been published recently, not recently actually, a while ago, stating that it's possible to actually make predictive paths for evolution of amino acids and peptide chains by RNA synthesis by simply pouring water over serpentine rocks. So under thermodynamic conditions, you can actually form sort of the precursors for living cells. And the reason I bring that up is that it makes me feel optimistic regarding the evolution of complex life. I don't think that complex life is I think it's sort of obvious. I don't think that complex life is a top-down process. I think it's the emergent property of being in the right conditional window in terms of complexity and thermodynamic state of the universe. So everything we see here on Earth, you have this concept of universality. It should be ubiquitous in our galaxy as any other galaxy, I think.
Yeah.
I mean, well, overall.
Yeah, like some examples are like L-amino acids are known to catalyze the synthesis of glyceraldehyde from formaldehyde glyceraldehyde from formaldehyde and glycoaldehyde. And the L isomer, which is the isomer of amino acids we use, will give you the D isomer of glycoaldehyde, which then can go on to produce ribose, which is of course a part of an RNA nucleotide. So it's like autocatalysis. And I think this also applies to like a lot of the B vitamins, because vitamins are also like cofactors of enzymes. They aid in catalytic activity. And oftentimes, B vitamins are involved in the synthesis of other B vitamins. So once you have all of those, like in an early cell, you can establish an autocatalytic network, one where the product of the reaction acts as a catalyst, and then as long as you're feeding it a reactant, the reaction network is always going to be expanding. And I think that was actually a key intermediate in the early development of life, where it kind of broke away from just being bound to local geochemistry and then start to become more and more autonomous as time went on.